So welcome back to the study hub, guys. So today we are going to discuss about the binary search. So basically there are two types of searching, binary search and linear searching. The main difference between the linear searching and the binary searching is the time complexity. Now in the binary searching, the complexity divided by the half. And complexity becomes the half as compared to the linear searching. So let's go and discuss with an example. And the first thing to implement an binary search algorithm is the array should be sorted. If array is not sorted, you can't apply the binary search on that array. So let's take an sorted array. Hope you are able to see this, because I'm not sure that you are able to see this example because the lights are too much high in this. So but I'm still giving you an example. So let's take an example 1, 3, 5, 7, 8 and 10, and we have to find an integer 7 is in this array or not. Okay, so this is our example. So we have to find the 7 in that array is present or not. So we're gonna take two pointers. First I and the second is j. The I should be pointed here and the j is pointed at the end. Okay, and we are gonna find the array dot length minus 1, and we're gonna find the mid in that. So we can find so basically the array is sorted. So if we find an array, suppose this is the mid, suppose for a while this is the mid. So if this is a mid, so before the midpoint, all the elements or the integer are smaller than that, and after this 7, all the elements are greater than the mid. So first we're gonna find the mid of this array. So basically the indexing 0, 1, 2, 3, 4, 5. So we're gonna find mid is I plus j by 2. J is pointing at the end or the last element in the array. So 0 plus 5 by 2 is 5 by 2 is 4. Okay. So 4 is this. So we're gonna check the mid element. If mid, so just understand this, if 8 we have to find a 7 and this is 8. So before the mid, all the elements are smaller. After the mid all the elements are greater. So just compare 8 or 7. 7 is smaller. Understand? So so we can find the 7 before the mid. So we're gonna shift this j up element before the mid. Okay, so this is our approach. So I'm gonna teach you just without any. So we're gonna shift the j before the mid. So mid is 4. So j is on the 3. So the array becomes 0 to j, and it means 0 to 3. So we again gonna find the mid. So now mid is 0 plus 3 by 2. 3 by 2 is 1. So our mid is now 3. So we're gonna compare 7 and 3. 3 is smaller, 7 is greater. So it means that the element is gonna be in the right side. So this time we're gonna shift our I next to the mid element. So now I is at the second index. So this time we're gonna again find the mid. Mid is like I plus j by 2. So I is 2 and j is 3. Yeah, and by 2. 3 and 2, 5 again. 5 by 2. 5 by 2. 5 by 2 is 2 to the 4, so it's become 2. So again 2, so 2 is smaller, so we're gonna shift our I again. Oh, sorry, 3 to 2 to the 4, yeah, our mid becomes this. So mid again is smaller, so I gonna shift this time again. So I is here, I plus j by 2. So I is same, 3 plus 3 by 2, 6 by 2 is 3. We're gonna add the third index. So we're gonna compare mid element at mid is equal to our target. So this time 7 is equal to 7, and we're gonna return from this, and we're gonna find our index. So basically in this approach, we're gonna take two pointers. First is pointing at the first, and the second is pointing at the end, and we're gonna find the mid element. And the approach is like, before the mid elements, all the elements are smaller than that, and after that element, all the elements are greater than that. Okay, so for this time, let's take an example and let's solve our LeetCode problem. So it's a better to give a better understanding. So let's solve our LeetCode problems on our LeetCode. So welcome to our study hub. So let's this is the time to practice the problem. So we're gonna take a basic example in which there is driver sheet in which we're gonna find the element in the nums array. The target is 9. Okay, so as we discussed, first we have to take the two pointers. Let's assume start is equal to 0 and int end is equal to nums dot length minus 1. Basically this is representing the whole array in which we are going to find the mid, so that we can compare the mid to the target. Okay, for loop int I is equal to 0. Oh, sorry. Sorry. We're gonna use this while loop for this time, because we are going to play with the start and end. That's it. So while start is smaller than end, because if start crosses the end or end crosses the start, it means the whole array is traversed, and that element is not present in that array. Okay, so and start and end, we're gonna find int mid every time. Start plus end, start and end divided by 2. So this is our mid. So if nums at mid is equal to target, so this is our answer. This is our index where the target is present. So nums mid is equal to target. We have to return mid. Okay, but if nums at mid is smaller than target, it means that target is greater than this. In this scenario, we have to shift our I. Okay, so sorry, we have to shift our start. So start become is equal to mid plus 1 this time, else we're gonna shift end is equal to mid minus 1. So basically this returns, and if the element is not, or the start or end crosses each other, it means the element is not present in that array. So we're gonna return minus 1. So let's try to run this. If there is a problem, we can solve it. Int mid is equal to start plus end by 2. Why it's showing error? Okay, we use this. Oh, I'm really sorry, guys. also it's working fine. So this is our binary search. Hope you are able to understand this. The main the main difference between the binary and the linear is the time complexity. So hope you are able to understand this, and meet you guys in the next video.